In this video, we're going to go through an integral review. These are all integrals that you should know how to solve before going into ordinary differential equations. If you don't know how to do these types of integrals before entering ordinary differential equations, then see your instructor, your tutoring center for additional support. These are all things that you should know how to do after coming out of Calculus 2 with analytic geometry, having completed Calculus 1 and Calculus 2. So our first one is going to be a basic U substitution problem. We have 5x square root of 3x squared plus 5 dx. U is going to be the inner function of 3x squared plus 5. That makes du equal to 6x dx. We have an extra 5 that we need to get rid of. So we're going to pull that out front since it's a constant. We're going to write this as u to the 1/2. Our x dx that's left is going to be 1/6 du. It's going to be x dx. So we're going to replace that with 1/6 du. The 1/6 is a constant that comes out front, 5/6. U to the 1/2 du. It's going to be 5/6 u to the 3/2 times the reciprocal of 3/2 is 2/3 plus c. 2 goes into 6 3 times. This is 5/9. U is 3x squared plus 5 raised to the 3/2 plus c. Number 2 is also a U substitution problem. 2 over the square root of x, 2 plus square root of x to the 3rd dx. The inner function here that we see is 2 plus the square root of x. That makes du equal to 1 over 2 times the square root of x dx. So we need to have 1 over the square root of x here. Dx is going to be 2, du is going to be 1 over the square root of x dx. I'm going to make my substitutions. That 2 can come out front. This is u to the -3rd du. This is 2 u to the -2nd divided by a -2 plus c is going to be a -1. And I'm going to put it back in fraction form, 2 plus root x to the 2nd, 1 over plus c. The integral of secant to the 4th x tangent squared x dx. I need to think about what I have that I want to take the derivative of to get something else. So the derivative of secant is secant tangent. Probably don't want to do that. The derivative of tangent is secant squared. That sounds right. So let me save a secant squared and change everything else into tangents using the identity that 1 plus tangent squared x is equal to secant squared x. We need to get rid of a secant squared x. It's going to be a 1 plus tangent squared x, tangent squared x times secant squared x dx. I'm going to save that over there because that's going to be part of du. So this is going to be tangent squared x, secant squared x dx plus tangent cubed x secant squared x dx. We're going to have u is equal to tangent x du is equal to secant squared x dx in both of these. So this is going to be u squared du plus u cubed du is going to be 1/3 u to the third plus 1/4 u to the fourth plus c. This will be 1/3 tangent cubed x plus 1/4 tangent to the fourth x plus c. Number 4, we have the integral of 2x minus 1 over the square root of x plus 3 dx. There's no nice u substitution to do here because I can't take the derivative of the inner function and get it up here. So instead, I'm going to let u be the entire square root here. I'm going to make this u squared is equal to x plus 3. And then I'm going to solve for x. And then I'm going to solve for dx like this. And that means that I have 2 times u squared minus 3 minus 1 all divided by u, and dx is 2u du. So we're going to multiply all this out. This is going to be 2u squared minus 6 minus 1 2u du over u. Those u's are going to cancel. And that's going to give me 4u squared du minus 7 integral du, like that. So that's going to give me 4/3 u to the third minus 7u plus c. U is x plus 3 to the 1/2. So this is 4/3 x plus 3 to the 3/2 minus 7x plus 3 to the 1/2 plus c. That's what the teachers call backward substitution, by getting that denominator that has the square root in it to be u and squaring both sides and solving for x and plugging everything back in the numerator so that I can have a monomial in the denominator and divide it out. All right, now we are to use integration by parts on these. Integral x over e to the x dx. Remember, with integration by parts, we want to use Liate to help us choose u and du and dv. Choose u from this side and dv from this side, where L stands for logs. Then I for inverse trig functions, A for algebraic expressions or analytic expressions, T for trig expressions, and E for exponential expressions. So Liate, remember that. So I'm going to rewrite this as x e to the negative x dx. I'm going to have x as my algebraic expression that I'm going to have equal to u. dv is going to be equal to e to the negative x dx since it's exponential. du is dx. V is negative e to the negative x when I integrate that. So my formula says the integral of u dv is equal to uv minus the integral of v du. So this is going to be uv negative x e to the negative x minus the integral of v, there's a negative in v, du, like that. So this is negative x e to the negative x. Then this is going to come out to be minus e to the negative x plus c. Number 6, the integral of x secant x tan x dx. Again, u is my algebraic expression here. dv is secant tangent dx. Derivative of secant is secant tangent, so the integral of secant tangent is secant. Du is dx. Again, uv minus the integral of v du. This one is tricky. You learned this one in Calculus 2. There's a couple of different forms for it, but it is going to be ln of the absolute value of secant x plus tangent x plus c. It's the way that I learned it. Now you've got the integral of secant cubed x dx. Keep this one with the integral written on the left-hand side. It's going to wrap around on itself. This is one of those ones like that. So u is going to be equal to secant x, and dv is going to be equal to secant squared x dx. Du is going to be secant x tangent x dx, and v is going to be tangent x. So integral of secant cubed x dx is going to be equal to uv secant tangent minus the integral of v du secant tangent squared, like that. Tangent squared is got a identity 1 plus tangent squared is equal to secant squared. So tangent squared is secant squared minus 1. I'll be using that to get this to wrap around on itself in just a second. This is secant times secant squared minus 1. So this is going to be secant cubed secant tangent minus secant cubed plus, because there's a negative negative, plus secant, like that. So we're going to bring the secant cubed over. We're going to integrate secant, which we just talked about. And I'm not going to do the plus c yet because I haven't solved for integral of secant cubed yet, but we will in this next step. It should look like that. All right. Now we're told to use trigonometric substitution on numbers 8 and 9. I do trig substitution a little different than a lot of the textbooks do because I start with my trig triangle. So I'm going to draw my triangle here and say that this side has to be 3, this side has to be x, this side is 9 minus x squared. This is theta. So my triangle is going to be defined in terms of sine of theta is x over 3. 3 sine of theta is equal to x. 3 cosine of theta d theta is dx. 3 cosine of theta d theta. X is 3 sine of theta, so x squared is 9 sine squared theta. And then this 9 minus x squared inside the square root sign is going to be 3 cosine of theta from the triangle. 3 cosine theta and 3 cosine theta will cancel. This is going to be 1/9. Integral of the reciprocal of sine is cosecant squared theta d theta. So let's think about, do we have an integral for that specifically? We do not. We have an integral for cotangent though. I'm sorry, yes, we do. We have, this is negative cotangent. Theta plus C. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. So there we go. We're going to go back and we're going to look for what cotangent is. Cotangent is going to be adjacent over opposite. So this is going to be 9 minus x squared over x plus c. It's negative 9 minus x squared over 9x plus c. Now we're going to deal with the integral of 25 minus x squared over x. This is 5. This is x. This is root 25 minus x squared. This is theta. So again, we're defined in terms of sine here. This x over 5. So 5 sine theta is equal to x. 5 cosine of theta d theta is dx. So this is going to be 5 cosine of theta times 5 cosine of theta d theta over 5 sine of theta. So that is going to be, these 5s will cancel, cosine squared theta d theta over sine theta. I'm going to change this into 1 minus sine squared theta d theta over sine theta. It's going to be cosecant of theta minus sine theta d theta. Integral of cosecant is negative ln of cosecant plus cotangent. That could also be cosecant minus cotangent. It's the same thing. Integral of sine is negative cosine. So negative negative is going to be positive plus c. We're going to come back to our triangle. And we're going to see that cosecant is going to be the reciprocal of sine. So that's going to be 5 over x. Cotangent is going to be adjacent over opposite. So that's also going to be over x and be root 25 minus x squared there. Cosine is going to be 25 minus x squared over 5 plus c. You may come up with other forms of the answer, but that is definitely trig substitution. That will work. Okay, now we're going to use partial fraction decomposition on 10 through 12. 5 minus x over 2x squared plus x minus 1 dx. 2x x plus 1 minus 1. 5 minus x, a over 2x minus 1 plus b over x plus 1 is equal to 5 minus x over 2x squared plus x minus 1. We'll get to the integrals in just a second. This is a times x plus 1 plus b times 2x minus 1 is equal to 5. I'm going to write this in this order, is equal to negative x plus 5. So this is, my x's are a plus 2b is equal to negative 1. And my constants are a minus b is equal to 5. I'm going to solve using the addition elimination method. I'm going to say that this means that, actually I'll substitute. Say that A equals B plus 5. And so B plus 5 plus 2B is equal to -1. 3B plus 5 equals -1. 3B equals -6. B equals -2. If B is -2, A minus -2 is equal to 5. So A plus 2 is equal to 5. A is equal to 3. All that is set up to say that A is 3 and that B is -2. That's equivalent to our original problem. So I need a 2 dx here so that I have du over u in the first problem. I do have du over u in the second problem. This is 3/2 ln 2x minus 1 minus 2 ln of x plus 1 plus c. Now let's go to number 11, the integral of x squared minus 1 over x cubed plus x dx. We factor the denominator, we have x times x squared plus 1. That's an irreducible quadratic that we'll have to deal with. Don't worry about factoring the numerator. There's nothing that cancels, so we're okay there. This is going to be a over x plus bx plus c. We need to go 1 degree less in this irreducible quadratic. So when we make a common denominator, like this, we're going to get ax squared plus a plus bx squared plus cx is equal to x squared minus 1. So my x squared terms are a plus b needs to equal 1. My x term c has to equal 0 because there's 0 for the coefficient there. And my a has to be, my constant part has to be -1. Well, that makes solving for b pretty easy. That's -1 plus b equals 1, so b equals 2. All right, come on back up here. A is -1. This is -1 over x. It's like that. Plus b is 2. And c is 0. That's easy enough. And so this is -ln of x plus, and this is already du over u, ln of x squared plus 1 plus c. Now we're going to solve number 12, 2x minus 3 over x squared minus 2x plus 1 dx. This has a repeated root in the denominator. So we're going to have a over x minus 1 plus b over x minus 1 squared is going to be equal to 2x minus 3 over x minus 1 squared. The common denominator is x minus 1 squared. This is a times x minus 1 plus b. It's going to be 2x minus 3. So let's go ahead and say ax minus a plus b is equal to 2x minus 3. That means that a has to be 2. For my constants, that means -2 plus b has to be -3, and b has to be -1. Two integral dx over x minus 1 minus 1 integral dx over x minus 1 squared. I'm going to rewrite that as x minus 1 to the -2nd dx because we're going to use the power rule. Don't need that -1 as a coefficient. It's just the subtraction sign. This is 2 ln of x minus 1 minus a negative 1 over x minus 1 plus c. Now we get to use the method of our choice on these remaining integrals. There's lots of them. I see that I've got a monomial in the denominator, so I'm going to use that to my advantage to say this is x dx plus 3 integral 1 over x dx, and give me 1/2 x squared plus 3 ln of x plus c. Number 14, I'm going to use u substitution. Let u be 1 plus ln of x. Du is going to be 1 over x dx. So this is going to be u to the negative 1/2 du. This is going to be u to the 1/2 becomes the reciprocal of 1/2 plus c. Going to be 2 times the square root of 1 plus ln of x plus c. I'll write it back with a square root since I had a square root to start off with. Number 15, 1 over 4 plus x minus 1 quantity squared dx. All right, this is a trig sub problem. Not a trig sub problem. This is an arctan problem, but I'm going to show you that it is by using trig substitution. So right here, this is x minus 1 on this side and 2, and this would be the square root of 4 plus x minus 1 squared. So we would come out to get this whole thing here would give me theta. Theta would be defined in terms of tangent of theta is equal to x minus 1 over 2. So let me just work it out here. So this is 2 tan theta is equal to x minus 1. That makes this that'll give me an identity in the bottom in just a second. That means that dx is going to be 2 secant squared theta d theta. Okay, so this is going to be 4 plus 4 tangent squared theta, 2 secant squared theta. This is just the way that a Calc 2 teacher taught me to do it recently. For students, we're going to pull that 4 out here, and I'm going to pull the 2 out as well. While I'm at it, this is secant squared theta d theta over 1 plus tangent squared theta. That and that cancel. This is 1/2 d theta. So it's going to come out to be 1/2 of theta plus c. Theta has been defined in terms of tangent. So theta is arctangent of x minus 1 over 2. And we knew that, but the formula says that it's 1 over a arctangent of u over a plus c if we had our formula memorized. If we didn't have our formula memorized, this is the process that we have to go through to prove the formula. But the process is not that hard. Cosine of x over root 4 minus sine squared x dx. Again, this is not looking like it's trig sub, but it kind of is. So we have a squared minus u squared here. So a squared minus u squared, like this. Here's theta, and that makes this side over here 4 minus sine squared. So sine of theta is equal to sine x over 2. 2 sine of theta is equal to sine x. 2 cosine of theta d theta is equal to cosine of x dx. So 2 cosine of theta d theta. And then down here is going to be cosine of theta times 2. So 2's will cancel, cosine of theta will cancel. We have d theta. It's going to be theta plus c. Theta is defined in terms of sine. So this is going to be arc sine of the sine of x over 2 plus c. If you just had the arcsine formula memorized, you'd be able to do that a little easier as well. 2x to the third minus 4x squared minus 15x plus 5 over x squared minus 2x minus 8 dx. So we want to do long division here because degree of the bottom is smaller than or equal to degree of the top. Divisor is not linear, so we can't easily use synthetic division. We're going to have to use long division. So this is going to be 2x, 2x to the third, minus 4x squared, minus 16x. Change our signs and add. Give me x plus 5. That degree is lower than this degree. This is x plus 5 over x squared minus 2x minus 8. So we have 2x dx plus x plus 5 over x squared minus 2x minus 8 dx. I'm going to try and do this without partial fraction decomposition. Can do this a couple of different ways. So I'm going to split this second integral now. This one's just going to be x squared plus, and this is going to be, I want to get no, I'll do partial fractions. It's going to be x minus 4, x plus 2, is plus 5. So we're going to have to split this into a over x minus 4, b over x plus 1 is x plus 5 over x minus 4 times x plus 1. This is a x plus 1 plus b x minus 4 is equal to x plus 5. Because I have all distinct linear factors, I'm just going to try and choose x values that make the parentheses 0. So I'm going to let x be negative 1. And that's going to give me negative 5b is equal to 4. B is equal to negative 4/5. Then I'm going to let x equal 4. That's 5a equals to 9. A is equal to 9/5. So we're going to have the first part of our answer was x squared plus a is 9/5 dx over x minus 4 plus minus 4/5. What did I write a b there? Negative 4/5, like that. There we go. Dx over x plus 1. So this is going to be x squared plus 9/5 ln of x minus 4 minus 4/5 ln of x plus 1 plus c. That was number 17. Number 18, e to the cosine of x sine of x dx. This is pretty straightforward that u is cosine of x, derivative of cosine is negative sine. So we're going to have e to the u du here, and it's going to come back to be e to the cosine of x, a negative out front, plus c. Integral of x plus 1 over x, quantity squared dx is going to be x squared plus 2 plus 1 over x squared dx. We're going to do each of those individually. That's 1/3 x squared, x cubed, plus 2x minus 1 over x plus c. Power rule on this one, where n is equal to -2, add 1 to the exponent, divide by the new exponent. Divided by -1 is going to change the sign. ln of x e to the x dx. So let's make this ln of x plus x, because when we have multiplication on the inside of the logs, that changes to addition of logs, like that. Ln, let me write it this way, sorry. Skipped a step, that's why, like that. And that ln of e to the x is the same thing as x, because these are inverse functions. So this is ln of x dx plus x dx. Ln of x dx we're going to have to do by parts. Say that u is ln of x, dv is dx, u is 1 over x dx, v is x, uv minus the integral of v du. This is going to be 1/2 x squared for this part. So this is going to be x ln of x minus x plus 1/2 x squared plus c. (21) is going to be integral of x sine squared of x dx. So we're going to let u be equal to x, dv equal to sine squared x dx. Chat, we're going to want to use a power reducing formula for this. V is going to be equal to the integral of sine squared x dx. So that's going to be the integral of 1 minus cosine 2x over 2 dx. That's going to be 1/2 x minus 1/2 integral cosine 2x dx. I'll need a 2 and a 1/2 here. 1/2 x minus 1/4. Integral of cosine is going to be sine, like that. So this is all what v equals. Du equals dx. So uv minus the integral of v du going to be we're going to need a two and a 1/2 here. So when I have 1/2 minus 1/4, it's 2/4 minus 1/4 is 1/4. One quarter times 1/2 is 1/8. We're going to need integral of sine is negative cosine. We're done. That was number 21. On to number 22. 1 over secant x tan x dx. So this is going to be, let's change this all into sines and cosines because I don't like the secant and tangent are in the denominator. This is cosine times cosecant, which is cosine over sine. That's going to give me 1 minus sine squared over sine. I did this exact problem before, just a little bit ago, I think. This is cosecant minus sine. This is negative ln cosecant plus cotangent minus a negative cosine plus cosine plus c. It's just a different form of the problem we did earlier. Integral of e over e to the pi x dx. E is a constant that comes out. We have e to the negative pi x dx. We're going to multiply by inside by negative pi and divide by negative pi on the outside. So this is negative e over pi, e to the u du, e to the negative pi x plus c. We could write this as a negative e to the 1 minus pi x divided by pi plus c if we wanted to, because when we multiply like bases, we subtract we add the exponents. If we wanted to write it more like how it was in the original, we can leave the e on the top, pi e to the pi x in the bottom plus c. That works just as well. That looks more like my original that I started off with. Let's try number 24 now. Root 16 minus 4x squared. This looks a whole lot like a trig sub problem to me. My hypotenuse is 4. My opposite side is 2x. This is 16 minus 4x squared. So this is 4 cosine of theta. Sine of theta is 2x. Cosine of theta d theta is 2 dx. Dx is 1/2 cosine of theta d theta. Half of 4 is 2. This is 2 integral cosine squared theta d theta. Cosine squared is 1 plus cosine 2 theta over 2. It's a power reducing formula. 2 times 1/2 is going to be 1 d theta, so that's going to be theta plus, I'm going to have 2 times 1/2 again, going to give me cosine of 2 theta d theta. I need a 2 and I need a 1/2 here. So this is going to be theta plus 1/2 sine of 2 theta plus c. Again, look at our triangle. Theta is defined in terms of sine. How did I write that? Like that. Hang on a second. Goofed. So this is over 4. So this is same as x over 2. 2 sine of theta is equal to x. 2 cosine of theta d theta is dx. All right. So this is 4 cosine of theta. And this is 2 cosine of theta d theta. That looks better to me. That's 8 integral cosine squared theta d theta. 8, 1 plus cosine 2 theta over 2. Pull the 1/2 out. This is 4. 1 plus cosine 2 theta d theta is 4 d theta plus 4 cosine 2 theta d theta. This is 2 over 2. This is 4 theta plus 2 sine 2 theta plus c. Theta is arcsine of x over 2 plus 2 sine of 2 theta is 2 sine theta cosine theta. This is going to be 4. The sine is going to be 2x. Cosine is going to be 16 minus 4x squared, both over 4. So 4 times 4 is going to be 16. 4 is going to go into 16. 2 is going to go into 4. We're going to have final answer of 4 arcsine of x over 2 plus x root 16 minus 4x squared over 2 plus c. Cosecant squared x over cotangent cubed x dx. This is going to be, let's make this tangent cubed over sine squared for the heck of it right now. And me think if that helps me at all. Let's get everything in terms of sines and cosines. This is sine cubed over cosine cubed. There's an extra sine squared here. That gives me a sine. Sine over cosine is tangent. Cosine bottom squared is secant squared. Derivative of tangent is secant squared. So this is 1/2 tangent squared x plus c. Number 26 is root x squared minus 1 over x root x. I'm going to write that x root x as x to the 3/2. Take 3/2 away from 2. I'm going to get x to the 1/2, x to the negative 3/2 dx. That's x to the 1/2 dx minus x to the negative 3/2 dx. It's going to be x to the 3/2 with the 2/3 out front minus x to the negative 1/2 times the negative 2 plus c. 2/3. That's it. Just going to leave it like that. That's all in terms of x already. Not going to go write it in square root form. So integral of e to the negative 3x dx, e to negative 3 and a negative 1/3, negative 1/3 e to the negative 3x plus c. Integral of 2x over 3x squared plus 4 dx. This is going to be a u du, where u is 3x squared plus 4, du is 6x dx. Multiply the top by 3 to get that 6x dx. 1/3 integral 6x dx over 3x squared plus 4. Give me 1/3 ln of 3x squared plus 4 plus c. integral of e to the x over e to the x plus e dx. The denominator here is u. E is just a constant, that doesn't bother me. So this is du over u. It's going to be ln of e to the x plus e plus c. X e to the 2x dx. U is going to be x. dv is going to be e to the 2x. du is going to be dx. V is going to be 1/2 e to the 2x. uv minus the integral of v du. Going to be 1/2 x e to the 2x minus 1/4 e to the 2x plus c. Number 30, integral cosecant cubed x cosine of x dx. Cosecant is the reciprocal of sine. So this is cosine of x over sine cubed of x dx. That might help me here. This is cotangent of x times cosecant squared x dx. Yes. So the derivative of cotangent is negative cosecant squared. So I'm going to do that. This is going to be a negative 1/2 cotangent squared x plus c. That's everything. Hopefully that helped you review your integrals, the basic integrals before going into differential equations. You saw that there were several different types there that are important for you to know. You're definitely going to want to know your U substitution. You're going to want to know integration by parts. You're going to want to know your trig sub and your inverse trig integrals. And you're going to want to know your exponential rule. And you're going to want to know all of your regular trig integrals as well. I think that was, oh, and you're going to want to know partial fraction decomposition. For sure. Those are all big things in differential equations. So again, seek additional help from your instructor or from a tutoring center at your school, or come see me for help through my Discord if you have problems with any of these types of integration before you start differential equations. Thank you. Have a good day.